Okay, hey everyone. So maybe we can get started. We will present you a peer-to-peer search engine for Solidity source codes. That's what we will do today. But first, before we start, so we are the Play project. I mean, we have some more team members, but they're not here today. And I would walk you quickly through what we did in the past. So we were working for a bunch of years on the Remix tool and brought it from basically nothing to how it looked before the redesign, for those of you who are familiar with it. Then we built like a smart contract UI, which basically helps you, it takes the compiler output of your smart contract and turns it into like an auto-generated dApp, so you can interact with it, you deploy and interact with your contracts. Then we built like a little editor that works in the browser where you can put like a code snippet or your smart contract in the browser, and it gives you the preview and you can deploy that directly from there and then interact with the smart contract to have it like lightweight and embeddable, really easy. And we built like a static workshop page generator. So you could use that embeddable tool to build relatively quickly some e-learning resources and put them onto your static page, so people can basically learn. You show them some tutorials, but they can already interact and do that in the browser. And if you do that, basically you just define a bunch of data and it turns it into this, so that's really quick. Then we have a bunch of people who already generated those, and if you do that, you can define other workshops, either done by you or by others, and those workshops would be maybe prerequisites for your workshop, so it automatically turns it into like kind of a skill tree. But this curriculum is not on one central platform, but instead it's decentralized because many different people maintain different workshops. Right, so that's our current team. Our current funding is quite low. We get like around $20,000 annually per person, and zero from other sources. But if you like our work and you have any idea how to help fund us, then please reach out. All right, so what's next? The next thing is we want to present you a peer-to-peer search engine for verified Solidity source codes. Now the question you might ask is, why would we do that? So the thing is, when we started teaching and showing people how they can basically deploy contracts and interact with them, we figured out that you have some kind of wallet and you might use MetaMask, or depending on what wallet you use, maybe a mobile one. It gives you a pop-up and you have to confirm your transaction. So when you confirm the transaction, you can actually check what it is that should go into this transaction, but what does it actually mean? So that's not so easy to directly see. So technically, you actually have to trust. So you have to trust traditional servers that they actually do what they are supposed to do. And on the blockchain, it's supposed to be trustless, but if you can't verify the source code, I mean, maybe you could use the bytecode and decompile and analyze, but it takes a lot of time. So in practice, technically, you're trusting that whoever deployed the smart contract didn't put in a backdoor or whatever. So that's kind of not a good situation. So as of today, there's like around 50,000 developers every month that are joining the ecosystem. There's like 1.5 million contracts getting deployed every month, and there's more than 10 million already on chain. And every day, there's more than 1.2 million calls to smart contracts, but there's only a few thousand verified source codes. So technically, everyone is trusting everyone else all the time, and that's kind of the same how you would do it with a traditional hosting provider. So what could we do about it? Maybe if there was a place to explore smart contracts and an API to verify, so you would download a source code, you would grab the bytes that are stored on the blockchain, then you compile the source code and you compare the bytecodes and you see, oh, this compiled source code has the same bytecodes than the one that you download from the blockchain, then you know this source code is actually the thing that is on the chain. So then you can either read it yourself or you can give it to somebody who understands it, and they might actually tell you that this is having a backdoor, or it's actually doing what it's supposed to do. So how do we approach this to get like some kind of neutral place where people could store their contracts, and so that we get maybe to a situation where we have hopefully all the contracts verified one day. So maybe a quick walk through the architecture. We don't have time to go into too much details, but basically you are running a node and you can run off one node of multiple nodes. You can also run all of them. So the first node is a DHT node, distributed hash table, and it's basically helping us with discovery. And we're piggybacking on existing ones, like from BitTorrent and others, so we don't have to run our own, because having enough nodes that this works is quite a challenge, so we're just reusing them. Then we have target list nodes. So they're supposed to, you can run your own and you add all the targets that you think should be scraped or having an API, so you can get them from that. And they're publishing themselves to the DHT, so other nodes can discover them, and then they download the targets. And the targets, it depends. I mean, anything can be a target. You can, on your node, run local tests if you want to include those targets or not. But that's more or less it. So they're not doing anything else than that. And you can publish new targets, and that's one thing. The next thing is a source code node. That works technically very similar. So you can run your own node, and you store your some source codes. And the source code node will publish itself to the DHT. So other source code nodes will discover those source code nodes and then download the source codes from those other nodes. So basically they're syncing. But before they add the source codes actually to their own storage, they will run, again, tests. And those tests, in the case of Solidity, would be just a verification. So you would download from the blockchain the bytecode. You check if whatever you received is actually a source code that is verifiable. And if it's so, then you will add it to your database. Otherwise, they don't do anything. The thing is, if any of the nodes goes down, then it works a little bit similar to like to BitTorrent. So as long as still some nodes are online, you will be able to get the source codes. And then we have scraper nodes. So scraper nodes are independently, anyone who runs them can get the targets from the target nodes and crawl them. And then when he gets a source code, he can publish them, and that's when the source code nodes will download them. So the source code nodes don't actually get any new contracts. This is done by the scrapers or anyone who individually uploads a node. And that's basically how the whole system works. And we're having a version that works right now. I mean, it's pretty pre-alpha and many things can break. But the thing is, what we are now currently working is a little bit of an improved how can we share the work of indexing? So the thing is, ideally, we want to, when somebody sends a query, we want to have every node, like let's say I'm searching for a source code or a code snippet and want to check if there's a source code that matches that snippet. So ideally, not a single node should do all the work, but maybe you would say if there's like 100,000 source codes, maybe every node can check a bunch of them, and then you start building indexes, and you can even reuse that. So to improve that, that's what we're currently working on. But in the meantime, we can show you smart contract.codes. So that's like a search interface for the source code. And that's maybe what Nina can show next.
Yeah, hi. So all this crazy technology is hidden behind this beautiful interface, and this is where you can search for the source code. So now imagine that you're a developer or like just somebody who wants to learn Solidity, or somebody who wants to search for some particular, I don't know, Open Zeppelin or some other import, or you're somebody who wants to find the verified source code. So you can go here, you can just browse through, or you can search for like, I don't know, DAO, and it will find you all the DAO contracts. So you can go through all of these pages. And when you open a certain, let's search for like, I don't know, what did we say? Basic token, for example. So this is reading all from the peer-to-peer database. We don't have a centralized server. This is like nodes running the database, and you can just search and get this interface window into this. And when you find a certain contract, you can open it in the editor. And currently the editor is still also, like, we have to fix some little things because it's really pre-alpha. We didn't launch even yet. We're just showing you what we are working on behind the scenes. So when you open the contract, you immediately get a preview. So this is like a visual interface of the contract. And now, basically, if you have MetaMask, you can just click publish and you deploy the contract. So you can actually fork it even with just like browsing through, clicking on it, and then just deploy it, and it's yours. And then you have it, and you can interact with it and use it as your own contract. What else is here? You can also search for particular code snippet, for example. So like keywords or the whole snippets. I hope it works. Yesterday it did, I promise. Yay. And I don't know, here is like a little thing that you can copy the address and go to Etherscan if you want to see some details, but later we want to also add, of course, like some stats about the deployed contracts. And if you just want to build your own new from scratch, you can just open the new editor, get like some basic what is this, even a demo contract, and I don't know, either delete it or work on it and then just build your own and deploy it. What else is interesting here? If you like the lighter theme, you can also switch to the, just because we have a designer, so I have to show off. What else? We're fetching the metadata, I mean, and then we get like the titles, and we get the address, when was it deployed, and the source code. So yeah. It's hard to show now how the data looks like, but it's like folders, and then you're just grabbing all this data and presenting it.
Yeah, you can basically on the terminal run some commands to clone. Oh. You could run some. Currently, it's not really yet documented, but if you're interested, I could show you how you can run some commands on the terminal to clone the entire database and run it yourself and help seeding it. So that's already possible. But the thing is that we are still thinking about changing the API to some degree. So we want to wait a little bit longer, but just to show you that it works, like we also in the last slide, I think, mentioned our chat. So if you join or afterwards, I can show you how you can already now clone the thing, but we will change the API, so we didn't yet write all the documentation down.
One more thing, if somebody goes and actually wants to try it, it will take probably a couple of minutes to initialize the database, because we connect to the node and then we start downloading all the data, so then you have it in the browser, and once you have it, you can actually even, I mean, I don't know if it now works, but it will work that you can browse offline. So this will take some time, and we have like some little notification telling you that this is not dead yet, it's just downloading, so just don't be afraid if you try to use it. Do we want to say some more things?
We can continue with the slides.
Later, I mean, if you will have some questions, I hope we have some more minutes, and then we can discuss. Sorry.
How do you deal with the fact that different versions of the compiler of Solidity bring you to different compiled code?
So the thing is, I mean, there's like some older compiler versions that don't require you yet to write a pragma statement. But usually all the new contracts, they have to have a pragma statement where they mention what are the compatible compiler versions. So we check the source code, and we also check all the imported dependencies. And then we compare all the pragmas and basically just use currently the lowest compiler version that makes sense for all of them, with all of them. And that's how we compile. But the thing is, that's also the reason why currently if you click some of the codes, they won't compile. Either because they don't have a pragma or maybe something else is wrong. So we will still need to check how to fix it. And eventually we will also allow you to manually set the compiler. But for now, because it was meant to not as a IDE or some development environment where you would actually build the code, but rather something where you can quickly see it and then basically fork it or interact with it. I mean, maybe you will do some changes, but I don't imagine that somebody would actually build a contract from scratch in that tool yet. So that's why we just thought if we choose the compiler automatically, it's faster. So people have to click less. But yeah, that's how we do it. We just basically automatically check what compiler version would work. Yeah, we had it. All right. So that's another thing. So we have like a little community-run charity project, you could say, where we basically promote a little bit earn while you learn and work remote culture. And we run this for some years, and we have like regular meetups, weekly meetups in Nigeria, Taiwan, Germany, and some other places. And we usually every year we do 1 month of free code camp. And this year we will actually do 2, and the code camps will actually be now in Thailand after DEF CON and in South Korea. So we're still, like, if you're generally interested in learning Ethereum and peer-to-peer and crypto stuff, you're welcome to join. Also, if you're a mentor and you want to join as a mentor, you're also welcome to join. So you can just reach out. And just to show you how it looked in the past, so these are some pictures from events in the past that we were running. And yeah, that's basically it. So just if you're interested in that kind of stuff, then just talk to us. All right, so thank you very much. Here are all the projects that we just quickly went through. The peer-to-peer search engine and the smart contract codes are probably the most important ones. You can find us on GitHub, and you can also join the chat. And if you have any questions, we can explain, or if you want to contribute or whatever, just reach out. Thank you.
Any more questions, maybe?
We thought about extending the search engine beyond just contracts. I mean, I know that your use case is a good one, but I wonder if people would be interested in like other.
Excuse me.
Yeah. So the thing is, all right. So the question is like, should we maybe use the search engine for something else or extend it beyond the current use case? So we were thinking, in order to publish something to the database, anyone could. But the thing is, we will only actually store it in other nodes if we can successfully verify the contract. So a node who receives a new contract would check, is it even Solidity? So can I compile it? And if I can compile it, does it match any code that is deployed to the blockchain? And if so, I store it, otherwise I just discard it. So if we would allow any arbitrary data, then it's kind of hard. What kind of tests would we run? But of course, once the system is more developed, it could be probably used for different kinds of data sets. Just somebody has to think about, unless they have no problem with storage, then maybe they can just run whatever and index any kind of data. But yeah, I guess this is basically like a search engine for just a certain type of data, and somebody could build a similar one for another type of data. But yeah, I mean, we kind of thought about it, but for now we thought we focus on this. Like even in our ecosystem, we could use different smart contract languages and not just Solidity, of course. But we just thought we have to start with one to build a prototype, and then we'll see.
One more question is, what's the current database size and how many contracts are you indexing?
So currently in the demo we have around 1,000, but actually currently we have around 70,000 contracts, but we didn't store them in a database yet because we first have to improve the work on the shared indexing. Because in the current system, if we would now put 70,000 in, I mean, it's already taking some time, and we have some ideas how we will solve that quite soon. But yeah, we're not ready for 70,000 contracts, and also not if there will be more. But yeah, I think soon we will.
Yeah, it would download probably like 2 hours or so.
Got it.
There was another question. Yeah, sorry.
It is about searching of the code snippet. Do you search exactly the snippet, or you can find snippets that look alike?
Yeah, right. So the thing is, currently we don't look exactly for the snippet. So we're having some kind of very basic mechanism to, for example, ignore white spaces and line breaks and a bunch of more things. But we don't yet, even though that's the plan for the near future, we don't yet use the abstract syntax tree. So we're just still doing the text-based search. But we have like a little prototype, which is not yet included in the live demo, who starts to use the AST, and then that's what we actually want to do. And ideally, but we don't know yet, we have some research papers for thinking about to build like a little query language that will actually help you to write like a query that looks more like code, but with placeholders, and then it will match a little bit more fuzzy or maybe very precise, depending on what you want, the code that matches it. But that's for now future. So if you would want to do it currently, I mean, as soon as we have the AST integrated, you would probably need to use JavaScript because it's in the browser and write like a function that would match the AST. So it's possible, but it's quite complicated. I mean, it's not nice to write. But yeah, but even now already, if you kind of don't have the line breaks or the white spaces right, it should still match. But yeah, it's pretty pre-alpha, so everything can break anytime.
Thank you.
I've quite a question, maybe a suggestion. Maybe it would be useful that somebody disassembles a contract and maybe add a little bit of comment to it and then put it in a system. And then somebody else can improve on that and you finally get the complete contract back.
Yeah, we were thinking about it too. And I think that would be cool because then we could just take all the millions of smart contracts and just put them in. But I'm not aware that I could, any disassembled code, if I could compile it back and then verify that this is actually the correct code. So doesn't matter if of course, if I initially got it from the blockchain, of course, I got the bytes. But the thing is, if I sync it in the peer-to-peer database, then somebody could just run a node and send me some stuff and say this is disassembled code. Okay, maybe you could write a test exactly to again download it, disassemble and compare the disassembled version with the one that we just got. Yeah.
In theory, you should be able to assemble it again or to
Right.
compile it
Or
again.
exactly, or every node would, then you wouldn't even need that kind of system. Yeah, you just everybody would download from the
Reverse
database and
engineer it
disassemble.
to Solidity
Yeah.
again, and then you
That's
can
true.
put it in your system again.
I mean, the thing is, we were coming more from the angle of the education, that we improved the developer experience. So we were thinking it would be cool to explore contracts and to learn, and then with the preview even see how Solidity works, and maybe also for other languages. And of course, then you can, once we have them, you can use them to verify. But if you use the disassembled one, I mean, you would probably also learn something, but then you wouldn't necessarily be able to build a smart contract. Unless you could recompile the disassembled one and you have a new language, or I don't know.
Yeah, I assume you would be able to reverse engineer the Solidity and then make readable Solidity out of that with a bit of manual work.
Yeah, that will be manual work. Yeah, right.
Yeah, and then people can improve on the manual version.
Yeah, I wonder though if we could. I mean, if you make Solidity from the disassembled code and then you could compile it, if you could actually be able to verify it, because the verification process is quite tricky, because for some reason when Solidity is written, the import paths, like, they matter. They somehow go into the process of verification for some reason. So if I'm having it and compiling it on my desktop and you're compiling it on your desktop, but your user home directory is different, then somehow that affects the verification. So, so there's like some, yeah, it's not that straightforward, even though it should be.
We have to go. We will be around if somebody wants to chat. We are like obviously obsessed with this, so come and and meet us. Thank you very much.